Hey everyone, Dr. Walker here. Hope you're having a great day. This is video 215. It is called Electric Potential Difference. So let's start off with a question. What does this mean? This is a 9-volt battery. You've heard of this, right? So what does this 9 volt actually represent? So please put your thoughts in the comments below. In this video, I like to talk about electric potential difference. So it is defined as the change in electric potential energy per charge. So that might be a little confusing, but if you look at this equation, it's actually similar to the definition of the electric field. Remember that definition? It was electric field is the force per charge. So it's very similar. And remember how the electric field told us about how much force that the charge would experience? And the potential tells us about how much energy that the charge has. So this is very similar. One way that you can think about is that if a charge moves through a potential difference, right? If there's a potential difference, if the charge is moving through that potential difference, then its energy will change. There's a change in potential energy. So that's how you want to interpret this. Let's look at this picture to help us out here. The same two plates that I love to draw. The positive charge here is just arbitrarily labeled as 100 volts and the negative plate 0 volts. We know that the electric field points towards a lower potential. So what we're going to say now is that there is a potential difference, a delta V, in between these 2 points because they are at different potentials. If we call this plate A, or point A is over here and B is over here, then we could also call this delta V AB the potential difference between points A and B, or from A to B. However you want to label it, usually for short we might just say delta V. So in this case, can you tell what is the potential difference between points A and B? To do this, you're always going to do the final potential, right, that you're going to, minus the initial potential. Remember delta, right? Final minus initial from physics 1. So 0 minus 100, so this would be negative 100 volts, would be the potential difference between A and B. And that makes sense because you're going to a lower potential, so that's a negative potential difference. So back to this definition. If a charge is moving, let's say you have a positive test charge here, is moving, right? It's moving through a potential difference. Since the potential is changing, it's decreasing. That means that its energy will change. And you can see from this equation, if it's going to a lower potential, then there's a negative potential difference. Well, there's going to be a negative change in energy, right? The energy is going to decrease, and that's what we talked about previously. I have a few more notes here. So the units for electric potential difference is the same as the units for electric potential because it's just a potential minus another, so it still has the same units as potential. And it's a volt, but I just wanted to make you aware that it's also a joule per coulomb, as you can see from this definition. Energy is in joules and charge is in coulombs. Whoops, coulombs. Remember that this little q, that's the test charge. Right? The test charge that is experiencing the change in potential energy. The test charge doesn't have to be there for there to be a potential difference, however, right? There's still a potential difference between these 2 plates, whether or not there's a test charge. Potential difference is a scalar, just like potential. And just to make things a little bit more confusing, this electric potential difference is also called voltage. So we see a lot of V's, delta V's, and volts, but it's just common usage of the word. Sometimes we'll say, what's the voltage between these 2 plates? But I'll try to say potential difference. Sometimes we also do leave out the word electric. We'll just say, what's the potential difference? Because people know that we're talking about the electric potential difference. Let's look at one question. Which is true about the potential difference from point A to B? Think about it, pause the video. So we just want to see if it's positive or negative. So from point A to B, that's again between A and B, we can think as A as being the initial point and B being the final point. You can imagine a charge moving from one point to another, but it doesn't have to be a charge there. So at point A, we are closer to the source. So we have a bigger potential at point A than we do at point B. Remember the equation for potential that we learned in the previous video, KQ over R. As R gets bigger, the potential gets smaller. So if from A to B, we're going to a lower potential. So if you do a small number minus a big number, you're going to get a negative number. If you go to a region of lower potential, then that means that the electric potential difference is negative. Vice versa, if you go to a higher potential, then your electric potential difference is positive. That's all for this video. I hope that you enjoyed it, and see you next time.